Hey Opties! Today we're talking about parallel lines in polygons, specifically triangles and parallelograms and trapezoids. So triangles and some special quadrilaterals. So the first type of example of triangle is a triangle inside of a triangle. We see that we have this kind of like the top of this picture is one of our triangles, and the entire triangle is our second one. So we've got two triangles though, and that's what we're going to be looking at. Notice we have these two lines are parallel to each other. We know that because of these arrows. And we have some angle markings and some segment markings to show congruence. Notice these two angles are congruent to each other, and these two angles are congruent. And think about if these are our parallel lines, we could extend them out. And it makes it a little easier to think about or to visualize when you extend lines. Kind of like it looks like over here in our second picture. So if we extend those, we can see that these are on the same side of this transversal. So this would be one transversal. They're on the same side, but one of them's interior and one of them's exterior. So these are not a same side supplementary, but these are corresponding. So they're in the same spot, different cluster. So that's what happens for both of these angles. We also see that we have these little segments are congruent to each other. So this segment and this segment. So where the ends of the parallel lines meet, or the segment of the parallel lines in our triangles. So it's kind of like where the bases of the triangles meet on their endpoints. Those segments are congruent. So let's say if you drew another line parallel to the other lines, so you can have three lines that are parallel to each other, then these two segments would be equal to each other or congruent to each other. So that's just an interesting example there. So if you have a triangle inside of a triangle, then you have corresponding angles. Let's look at our second example, triangle made by two transversals. And I have a little note here to treat each transversal individually in order to really see the relationship. So if you look at this transversal, let's say you're looking for same side interior, it'd be this angle and this angle. And I'll draw different angle markings to show they're not congruent. Notice that this double arc marked angle kind of goes past this other transversal. So we're kind of ignoring it when we look at same side interior here. Let's say we're looking at this other transversal and we want to do same side exterior for supplementary angles. So we've got this angle and we're going to ignore this angle and look at this parallel line and this transversal. So same side exterior, that's going to be that angle. So you really have to think about it. And what would be really good is if you have some colored pencils or some different colored markers or highlighters to highlight or color code those two different transversals if you have a situation like this. That will really help you keep track of those. Let's look at our parallelograms and our trapezoids. So first we have two parallelograms and they have two sets of parallel lines. So let's look at this first parallelogram. As we're looking at the horizontal lines as our parallel lines, and let's treat these other lines as our transversals. So these would be on the same side and they're interior, so they're supplementary, same side interior. And these are also same side interior. So those are all supplementary to each other. But if we look at these lines as our parallel lines, because remember they have two sets, so you can look at it two different ways. These are same side interior to each other, and these are same side interior to each other. So let's draw arrows to represent that. These are same side interior, so that means they're supplementary. Remember, same side supplementary. So are these. And then we've got these are the same side interior. You can, of course, look at all the other relationships for parallel lines cut by transversal, but the most obvious and the most applicable for parallelograms are the same side interior, because those are the interior angles of the parallelogram, so the angles on the inside of the parallelogram. So that's why we're going to look at those. Let's look at our trapezoids. The first is a right trapezoid, which means it has one right angle, which if that one's right, this one's also right, which is just something extra you would know. You only have to know that one angle is right to figure out the rest, but that's good to know. Okay, so we've got, these are our parallel lines. So these are going to be same side interior. So they're same side supplementary, right? They're supplementary to each other. And these are also same side interior, and they're obviously supplementary because 90 plus 90 is 180. So even if you don't have a right trapezoid, like this trapezoid over here, this is just a regular old trapezoid. It's not right, it's not isosceles. Isosceles means it has opposite set of sides are congruent. So that's another type of trapezoid, but that's just a regular old trapezoid. And these are going to be our same side interior angles, which would be supplementary. And these would be the other pair of same side interior, which are supplementary. So notice they have to be the ones that are, the angles that are supplementary to each other are on the parallel lines. So it wouldn't be these two angles because those are on the same parallel line. It has to be on two different parallel lines. Otherwise, it's not same side interior at all. If it helps you to also draw out the transversal longer, go ahead and do that. It's just up to you, whatever helps you. Let's look at some practice. Number 1 says, given the image below, what is the value of x? So we discussed how in two triangles that are one's inside the other, that's going to be an example of corresponding angles. We can also tell that they look about the same. And I like to think about this as taking an image, like on Google Docs or something, or Google Slides, and if you extend it, it's going to get bigger in size, but the angles are not going to change, and that's what's happening here. So we'll learn later that these are similar triangles, and furthermore, they're dilations of each other. So that's a little bit extra info there, but we know that these are congruent angles. We'll draw our arc marks, and if we want to find x, we can just set these expressions equal to each other. So 2x plus 6 equals 5x minus 30. So we could subtract 2x from both sides, and that's 0. And 6 equals 3x minus 30. Let's add 30 to both sides. 36 is equal to 3x, and we'll divide both sides by 3. And x is equal to 12. So we're done with number 1. Let's look at 2. Use the diagram below to determine the measure of angle 1. So we have 65 degrees, 60 degrees, and then we have an angle 1 here. Okay, remember we treat each transversal separately. It looks like we're going to be operating on this transversal, so I'm going to go ahead and trace that. Angle 1 and angle 60 are technically on this other transversal, but 65 is not. So that's how we know we're going to be using this transversal. So if we look at this angle, we're either going to be looking for a congruent angle or a supplementary angle. So let's look for the congruent angle to this, or one of the congruent angles. Well, it could be this angle. That's a corresponding angle. But what's left over to make a line is all of this angle. So I'll mark it differently to just show that they're not congruent. And I'll mark this differently too because I don't want it to look like it's the same as 1. So 60 plus the measure of angle 1 is equal to the angle that's supplementary to 65, and that would be the same as this angle. So 60 plus the measure of angle 1 is corresponding to this angle down here, and those are a linear pair. If you want to use the direct vocabulary for 65 degree angle and the 60 degree plus the measure of angle 1 degree angle, that's going to be same side interior. So let's write that same side interior, just a little abbreviation there. So regardless, they're going to be supplementary. So we could write 65 plus 60 plus the measure angle 1 is 180. So let's just do that. 65 plus 60 is 125 plus the measure angle 1, and that equals 180 degrees. So to solve this for measure angle 1, we'll subtract 125 from both sides. This is 0, and then we have the measure angle 1 is equal to 125 minus 180. So 25, 35, 45, 55, 65, 75, 85. That's too much. So it's not 60, it's 55. Okay. So the measure angle 1 is 55, and we're done with number 2. Number 3. Below is a parallelogram formed by parallel lines cut by 2 transversals. 2 consecutive angles are marked 6x and 3x respectively, as shown below. What is the value of x? Okay, a lot of language to show us, hey, let's find x. I do want to make sure we understand what the word consecutive means. Consecutive just means one after the other. So 3x comes right after 6x. They're also adjacent, so that kind of goes together. And respectively just means in the order that is listed. So 6x and 3x, well, 6x is listed first, then 3x, and 6x comes before 3x in our picture. So that's all that means. Okay, so let's find the value of x. These are going to be same side interior to each other. Remember, that's the main vocab we talked about for parallelograms. We know that because they are on the same side of this transversal, and they are interior to the parallel lines. So same side interior, that's the same side supplementary relationship. So we'll add these together, 6x plus 3x, and equal them to 180 degrees. So 6, 7, 8, 9x is 180, and we'll divide both sides by 9, and x is equal to 20. All right, lastly, we have number 4. It says find the value of x in the image below. Okay, we have a trapezoid, and it's a right trapezoid. It's just for kicks and giggles. Let's mark this as a 90-degree angle. We won't really need it, but that's fun to know. Okay, so these are same side interior. So they're supplementary. So let's add them together to equal 180. So x plus x minus 20 is equal to 180. So that's 2x minus 20 is equal to 180. We'll add 20 to both sides, and that's a 0. 2x is equal to 200, and we'll divide both sides by 2. That's a 1. And x is equal to 100. All right. Just for fun, I want to make sure we understand, like, what would you do if it asked you for the measure of an angle? Well, if it asked you for this angle, well, that's just 100 because it's exactly x. And if it asked you for this one, that's going to be 80. You could know that by doing 100 minus 20 by substituting our x value in here. Or you could say, okay, well, these are supplementary. If this one's 100, this one has to be 80 to make up that 180. All right, that's it for parallel lines and polygons, notes, and practice. See y'all next time.